After one-dimensional or single-dimensional arrays, the next most common type of array is the two-dimensional array. That's an array that stores rows and columns of data like a spreadsheet. Let's start by looking at how you declare such an array. You start with the data type of the array, followed by the name of the array, followed by the number of rows that the array is going to hold and the number of columns. So for example, this declaration would declare a 2 by 2 or 2 row by 2 column array. If we wanted 5 or 6, let's say 6 columns instead of 2, then we change the column number to a 6. Just like with one-dimensional arrays though, it's better to use constants here. So what I want to do is create a constant called rows and set it equal to a value, and then create a constant called cols for columns and set it to a value. And then in the declaration, I'll replace those literals with the constant names. That's a much better way to declare an array. Another way to declare an array is to provide an initialization list, just like we could do with single-dimension arrays. Here's an example. Let's say I want to keep track of a set of temperatures, and it's going to have 2 rows and 6 columns, just like our example above, so we can declare the rows and columns like so, and then we can provide an initialization list. That list starts with an open curly brace. Then for each row, we open another curly brace and then provide the data. So I'll just write in a string of temperatures here, 89, 94, 88, and 90. That represents the first row. Then I type a comma. Then I'll come down underneath the first row and write the second row, 79, 86, 85, 93, and whoops, I left out one, and 88, then 93, then 91. Not that it really mattered. Follow that with a semicolon, and now we've created a 2 by 6 array. Going back to our first example for numbers, if we want to initialize that array to zeros for each row column position, sometimes called a cell, using spreadsheet terminology again, we'll write a nested for loop. A nested for loop where the outer loop controls the rows, as you see here, and then an inner loop controls the columns. So we'll write C less than cols plus plus C or C plus plus, which you don't ever write because then you get confused with the language. So let's go back and make this uniform. But remember, of course, that where you put the increment operator in these situations makes no difference. It can be before or after the variable. Either way is fine. So then the body for the loop will consist of an assignment to each value of R and C, or row and column, and assigning each one of those a value 0. So we're saying, let's look at the very first instance when the loop runs, R and C will be 0. So we're saying set position 0, 0 to 0. Then the next time through the loop, C is incremented, so we'll be at position 0, 1, and we'll set that to 0. Then we'll move up to 1, 0, and then 1, 1. We can display those results by just taking the same loop that we just wrote, copy it, and then instead of doing the assignment, we want to display the data. So we're going to write out numbers R, C, and then let's put a space there. So let's build and run that program. And there we see that all the elements of the array are zeros. Now what would really be better would be to display the array in the structure that we set out for it, where there's 2 rows and 7 columns. So to do that, all I have to do is put an open curly brace to make the outer loop a multiple statement. And then when the inner loop is complete, in other words, when we've written out one complete row of data, then we want to write a new line so that we'll move down to the next row. So that should work. Let's build and run the program. And there we see we have 2 rows of 6 columns. Let's take that same loop, and this time rather than work with numbers, let's replace that with temps so that we can see how it looks with data in there. Shouldn't be any difference. Build and run. And there we see our temperatures that we assigned. So when you're working in row order from the first row to the second row to the third row, this nested for loop pattern will always be used. In fact, we're going to look at that right now. Let's write a more complete example. So what I want to do is write a grading program that takes a set of grades for 5 different students and computes the average for each student. So the way I want to start this program is by creating my rows and columns sizes. So we're going to have 5 rows and 5 columns. We need a variable for the total. We'll call that total. And then we need a variable for the average, which we'll call average. Now we want to create the array. We'll call it grades. And we will use an initialization list to assign grades to the array. So here's my first set of grades. Close it with a brace and then a comma. Then scoot over and do the second set. 89 is the last grade. Another comma. So 92, 91, 94, 89, and 90. There's the third student. The fourth student, 74, 72, 81, 78, and 80. And now we're ready to do the last student. 84, 82, another 82, 83, and 81. Close off the list and then type a semicolon. Move back over to the beginning of the line. Now we're ready to loop through each row and compute the average for the row because each row represents a student. So we start out with the for loop, int r equals 0, r less than rows, plus plus r. Now right here we're going to write out a label. So we're going to represent the student as being r plus 1 because there is no 0 student. There's always the first student and the second student. But because we begin counting at 0 in array positions, we have to add 1 to r. So there's the cout to represent the student. Now we have to go through and add the grades for that student. So now we have to work through the columns. So our inner loop works from 0 to the size of the columns. In this case, we need a body because we're going to have more than one statement. So the first thing we want to do is write out the grade, followed by a space. And then we want to take that grade and add it to the total. So we do so like this. Close it off. So that will go through one row. Let's take the first row for example, and it will print out 75, 82, 84, 79, 91, and then it will add up the grades together and store them in total. Then we're ready to print out the average, so we write average is equal to total divided by the number of columns we've been through. Then we write out the average with a little header. Then, before we do the next student, we need to reset the total and reset the average. Close off the inner loop, and now we're ready to build and run to see if the program works. And there we go. So if you look at the output, student 1 had a 75, an 82, an 84, a 79, and a 91 for an average of 82. Student 2 had an average of 89. Student 3 had an average of 91. Student 4 had an average of 77, and student 5 has an average of 82. Let me close that out so I can emphasize something in the program. The important part is to remember that after we've gotten the total, then we have to compute the average, write it out, and then reset total and average before we increment the next outer loop. That's just a standard pattern for when you're working row by row in a two-dimensional array. And that works for all two-dimensional array data when you're working by rows. In the next video, I'll demonstrate how to work by columns so that instead of looking at the average for each student, I can look at the average per grade. Say if each one of those was a test, test 1, test 2, test 3, test 4, and test 5, I can see the average for each one.